Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Miftakhul Hakam. In this opportunity, I would like to present our research with the title From a Cheap Nickel Source to High Performance NMC in more ratio 5:3:2 cathode material. The battery challenge predicted that lithium-ion batteries would remain the dominant technology in the future. Since lithium-ion batteries are suitable for storing high-capacity power, they are used in various applications such as smartphones, PCs, industrial robots, production equipment, automobiles, and electric vehicles. And then why using NMC? NMC is one of cathode material in lithium-ion batteries. NMC offers a unique blend that lowers raw material costs due to reduced cobalt content. It's highlighted that nickel content besides the others, which is an essential component for cathodes of many secondary battery designs, including lithium-ion batteries. Nickel-based systems have a higher energy density, lower cost, and longer cycle life than cobalt-based cells. In this research, we synthesize NMC in mole ratio 5:3:2. In this research, we use mixed hydroxide precipitate as nickel source to produce NMC cathode materials. Mixed hydroxide precipitate contains 35.2% of nickel, which is higher than the other component. However, the impurities can be used as doping for NMC cathode material. Mixed hydroxide precipitate has advantages such as reducing the cost, being easy to process, having greater storage capacity, and high availability in Indonesia. Here is the methodology to produce NMC 5:3:2 cathode material. The first step is leaching process. After the leaching process, we add manganese sulfate, cobalt sulfate, and oxalic acid to get NMC 5:3:2 oxalate precursor. And then we etching overnight to get the precursor. After that, we calcinate the precursor by adding the lithium carbonate in excess 10%, and then we are sintering the material to get NMC 5:3:2, and then we pulverize the cathode material. In the calcination process, the temperature is 500 degrees Celsius, around 5 hours, and then the sintering process, the temperature is 950 degrees Celsius in 20 hours. Here is the characterization of the NMC 5:3:2 oxalate precursor using XRD and FTIR tests. From the XRD test results, a sharp peak indicates the sample has a good crystal structure. However, on the test result curve, there are still small peaks that indicate the presence of impurities, such as oxalate groups, which causes the precursor to be amorphous. From the FTIR test, there are some functional groups in organic compound that indicates function of oxalate groups. And there are the characterization of NMC 5:3:2 oxalate precursor using scanning electron microscopy in some various magnification. The calcination and sintering process of NMC 5:3:2 material was analyzed by thermal gravimetry, resulting in 3 reaction interpretation zones. In Zone A, Stage 1 dehydration process occurs, and in Zone B, Stage 2 dehydration process occurs. Zone C is the zone where the calcination and sintering process occurs. In this zone, the oxalate group in the precursor will burn so that the NMC532 precursor will react with lithium from lithium carbonate to form NMC532 material. And in the red line, there are three peaks, two of which are downward peaks and one upward peak. The downward pointing peak indicates an endothermic reaction. Meanwhile, the peak facing up is an exothermic reaction. And the next slide is characterization of NMC532 material as final product that we synthesize from mixed hydroxide precipitate, and from XRD pattern we comprise by NMC532 material commercial, and we can conclude that high crystallinity and no impurities in our products. And from the FTIR spectra didn't show any organic groups, which indicate that synthesizes from a mixed hydroxide precipitate to NMC532 was going well. And the next is the characterization of NMC532 material using scanning electron microscopy in various magnifications. And there are the electrochemical performance tests of NMC532 material that we synthesize from mixed hydroxide precipitate. So the test with charging up to a voltage of 4.25 volt, the curve shows a specific charge capacity of 179.14 milliampere hours per gram and specific discharge capacity of 111.19 milliampere hours per gram, leading to capacity loss in the NMC532 cathode battery sample. And there are the cycle tests on the battery. Despite the decrease in specific capacity in the cell, can still deliver a power of 39.83 milliampere hours per gram at very high currents. The conclusion from our research, the XRD analysis of NMC532 shows high crystallinity and no impurities. Also, the FTIR test didn't show any organic groups, which indicated the process was going well. And then from thermal gravimetry test, the process from differential thermal analysis and thermal gravimetry, the dehydration process in stage 1 with mass reduction of around 5%, while the stage 2 with a mass reduction around 15%. The calcination and the sintering process results in a mass reduction of around 42%, with burning of oxalate groups in capacity of energy burning around 891 joule per gram, and the decomposition of lithium carbonate and the formation of NMC532 material. And then the electrochemical performance, there are the specific charge capacity was 179.14 milliampere hours per gram, and the specific discharge capacity was 111 milliampere hours per gram. This is enough from our research. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.